All right, welcome to The Explainer. Today, we are tackling a really big one. Elon Musk's absolutely audacious predictions for the future of artificial intelligence. And trust me, it's a wild ride that starts with something as simple as a power outlet and ends up, you guessed it, on the moon. Yeah, I know what you're thinking. That sounds completely nuts, right? Pure sci-fi. But here's the thing. It's all based on a very real, very physical problem we're facing right now, right here on planet Earth. And the problem isn't about code or algorithms. Nope. It's way more basic than that. Think of it like this. Our appetite for digital stuff is getting bigger and bigger, but our plate, the physical world, is staying the same size. Something's got to give. Okay, so this is the heart of it. The need for AI compute power is just shooting for the moon, right? It's exponential. But our ability to actually make the electricity for it, well, it's pretty much flat, especially if you're not in China. You can't just wish for more power to turn on all these new chips. The math just doesn't work. And this is where people who live in software land get a rude awakening. You can't just push a button and deploy a new power plant like you're updating an app. Building real physical infrastructure is just incredibly hard and slow and, yeah, super expensive. I mean, just think about it. You're fighting for years just to get the permits for the land. Then you got to convince the utility company to connect you, and they might spend a whole year just thinking about it. And let's say you get past all that. The parts you need, like turbine blades, they're literally sold out until 2030. The real world just moves at a different speed. So if building on Earth is such a nightmare, where do you go? Well, the argument here is, you go up. Space has this one huge, unbeatable advantage when it comes to the best power source we've got, our sun. You know, it's always sunny in space. There's no night, no clouds, no weather. Heck, there's no atmosphere getting in the way, which by itself sucks up like 30% of the sun's energy. So you put a solar panel up there, and that same exact panel generates about 5 times more power than it would down here. But wait, it gets better. Since the sun is always shining, you don't need giant, crazy expensive battery farms to save up power for nighttime. When you take those out of the equation, the argument is that solar in space is actually up to 10 times cheaper. 10 times! Okay, problem solved, right? We've got infinite power for infinite AI. Well, not so fast. It turns out fixing the power problem just shows you what the next massive bottleneck is. It's the chips, the actual silicon. See, the giant factories that make these things, they're called fabs, are unbelievably complex. It takes a solid 5 years from the day you start digging to the day you're cranking out high-quality chips in huge numbers. And we just can't build them fast enough for what's coming. And this isn't a money problem. You could throw all the money in the world at it, and the big players like TSMC and Samsung, well, in Musk's own words, they're already going balls to the wall, and it's still not enough. They physically can't build these factories fast enough. So what we're talking about here is a need for a totally new kind of factory. People are calling it a terafab, something orders of magnitude bigger than what we have now. But if it takes 5 years to build one here on Earth, how on earth do you speed that up? So you've run out of power on Earth. You've run out of factory capacity on Earth. Where do you go? This is where the whole idea takes a giant leap, right off the planet. Okay, strap in. The endgame here is basically industrializing the moon. The idea is to mine the lunar soil, which is full of silicon and aluminum, exactly what you need, and use it to build the big, heavy stuff for the satellites, like the solar panels and the cooling systems, right there on the moon. And then you launch these completed AI satellites into space with a giant electromagnetic catapult, a mass driver. And to give you a sense of the speeds we're talking about, it would launch them at over 2.5 kilometers per second. That is insanely fast. And according to this whole vision, this is the only way you can get to the kind of scale we're talking about. A petawatt of compute per year. A petawatt, that's a 1 with 15 zeros. It's an absolutely mind-boggling amount of power. We're talking about an astronomical scale of intelligence. And at its peak, this moon factory could be launching 10 billion tons of stuff into space every single year. Let that sink in. That's more mass than everything we ship on all the oceans of the world combined. You can't do that from Earth. Our gravity's too strong. It's physically impossible. So you might think this is all just a crazy engineering project to build better AI, but it's actually about something way bigger. It's about fundamentally changing what intelligence even means. Because if you follow this logic, you get to a future where our intelligence, human intelligence, is less than 1% of all the intelligence that exists. We become a tiny, tiny fraction of the whole. So, that brings up a pretty big question, right? Why? What's the point of all this? Well, the official mission, the whole philosophy behind this, isn't just about making a smarter search engine. The stated goal is to build an AI that is maximally curious, an intelligence that wants to understand the universe. And the thinking goes something like this. If you create something that is truly, deeply curious, it wouldn't want to destroy interesting things. It would want to observe them. So a maximally curious AI would want to see how our story, humanity's story, unfolds. Keeping us around becomes, just a logical thing to do. And really, that's the whole idea in a nutshell. It starts with a very real problem, not enough power plugs on Earth, and ends with a superintelligence exploring the cosmos. It's a vision that forces us to think not just about technology, but about our own place in the universe. So if the future has 1,000,000 times more silicon intelligence than us, what exactly is our role in it?